Hello everyone, myself Sajjal Suni. Uh, Today in this video, I am going to explain the STL library of C++. I was actually going uh, revising my data structure and algorithms uh, concept. So I was going through STL library. So I thought I should basically make a video on STL library and spread the knowledge uh, in the uh, competitive programming community. So yeah, so starting with what is STL basically? So STL is basically a standard template library in C++, which is basically used in competitive programming for uh, writing code fastly, and there are a lot of inbuilt things there in STL library which we can use and implement implement things faster. There are three things mainly. First one is containers, second one is algorithms, and third one is iterators. So what are containers? So containers are basically a kind of data structure uh, data that are pre-built in STL and which we can directly use for solving competitive programming and DSA problems. So for that, for using this STL library, what we have to do, we have to basically include this has include bits std++.h. This directive will basically include all the libraries that we can use in solving a data structure and algorithm problem. So I'm starting with one by one. So yeah, so there I'm going to start with sequential containers. So what are sequential containers? So sequential containers are basically an example vectors. So vector is basically a um, kind of array which whose size can be dynamically increased and shrink also. So how we can create vector in C++? Uh, let let's see. So suppose I have to create a vector. So what we can do? We can basically write vector angular bracket and type of data type of vector. So in data type. So yeah. So so now we have created a vector. So now what is the memory of what is the size of vector right now? If we can see by using cout, then v dot size by running the program, we can see that the size of the vector right now is 0. Now, since vector is dynamically, its size can be dynamically increased and decreased. So what we can do, we can basically push an element. So for pushing an element, we can use a function v dot push back. Here we can pass a element as a argument. Uh, so again, some other element v dot push back to. So now, what is the size of a vector now? Let's see. 2. So since we push two elements uh, in the vector, its size is 2. So what is the capacity is also one property. So what is the capacity? So we dot so capacity is uh, basically a property which determines the memory allocated to the vector. So since I haven't initialized any capacity in the line number 7, so after pushing two elements in the vector, its size is 2 and capacity is also 2 because memory allocated is also uh, two subsequent uh, two subsequent blocks in a consecutive manner. So capacity is also 2. Now, what we can see, for suppose you have to check that whether a vector is empty or not. So there is one more property. So vector v dot empty. So since it's written a value 0, so what does it mean? It means that vector is not empty because it has two elements put before, so it is not an empty vector. So suppose uh, there is one more property, v dot clear method. So by doing this, what is happening that all the elements, uh, all the element that has been pushed in the vector has been flushed. So now if we see the v dot size of the vector, so it should be 0, right? So suppose we see the vector size now, so it should be 0 after clearing v dot clear. So yeah, it is 0. So now again, uh, I'm going to use the v dot empty. It should be 1 now because I have cleared the vector size to 0. So now the vector is empty, so it is returning the value 1. So for suppose I want to iterate the vector. So what can we do? So for iterating the vector, what we can do? We can do auto element of vector. So if I do out element and removing these lines of clearing the vector. So yeah, so what should be print? One and another line two. So let's check. So yeah, so for iterating the vector, what we can basically use the for loop also. Another way of iterating the vector is using for let sorry for int I equal to 0, I is smaller than v dot size. So yeah, in this way also we can iterate vectors like I equal to 0, I smaller than v dot size, I plus plus, and vi. There is also one more property like removing the last element of the vector. So for that also we can use v dot pop. So now if we see the size of vector, sorry, it is pop back. So you can see that after doing the pop back, the resultant is 1. It means that the last element has been put and the size of the vector has shrunk to 1. Yeah, okay. So again, what we can do, we can basically declare a iterator also by declaring the iterator equal to v dot begin and dereferencing the iterator. So by differentiating the iterator, we can also iterate in this way also. Like what a iterator v dot begin does, that it basically uh, gives us a pointer which is basically pointing to the first element of the vector. So by dereferencing it, we can basically access the vector elements. So yeah, so vector is what we can do. We can use basically vector in place of uh, array also, and like we can like do things easily like pushing element in the vector, popping the last element. We can basically check the uh, size of the vector and many other things. So yeah, so this is all about vectors in STL library. So now there is uh, another property in um another property in ordered container. So one another property is DQ. So what is DQ? DQ does DQ is basically a queue which is basically open from both side. Like uh, we can basically push element in the queue, but we can basically pop from front side and back side both. So let's uh, try to play with DQ also. So yeah, so in this way, what we are doing that we have created a DQ and we are pushing element into it, and also by doing push front, what we are doing, we are basically uh, pushed the element from the front side also. Uh, in the line number 8 and 9, we are pushing elements in the queue from back, and in line number 10, we are pushing the push the element from front also. So you can see that from both front and back, you can push element in the queue. Now, suppose you want to iterate queue. So what you can do? suppose I do dq dot pop front. So now if we do the iteration again, so what should we print? Let's check. Yeah, so dqq dot pop front I run. And after that, mm, yeah, so you can see that I have removed the like the front element from the deck, and after that uh, I was uh, I iterated, so it's giving one and two. So yeah, so what was happened earlier that since I created the iterator before popping the popping the first element. So what it does that it uh, it was actually pointing to the reference. It was pointing to the address, but after that we does the pop dot front. So that's why it it actually print the equated to the address because it hasn't like garbage collected from the address. So that's why uh, if we declare the iterator before doing the pop front, it will print every element that has been pushed in the DQ. So property that same property that we can basically DQ dot pop back also, like similar to pop front, that removing the back element from the DQ, and again iterating it will basically remove the uh, back element from the queue, and after doing if we do iteration, it will basically uh, from the front side it will iterate to the last element of the DQ. So yeah, so very same to vector also, it has more property like empty, which will basically uh, check the whether DQ is empty or not. If it is empty, then it will give the value 1. If it is not empty, then it will give the value 0. Yeah. So uh, list is also a kind of container also. It is basically a linked list, actually doubly linked list, through which we can basically iterate through all the we can basically create a linked list. Uh, Otherwise, we will have to do our uh, we will have to create linked list from scratch. Right? STL provide a list kind of container which is build linked list, what we can do, we can basically push element in the linked list. We can push like create a node in the in the last and in the front, and we can basically iterate. Since it is a doubly linked list, so we can go, like iterate uh, in left direction, right direction both. So let's come to another container, which is uh, set. So it is basically an sorted container. So what set is? Set is basically uh, in basically a heap data structure, and which is uh, if you see that is in an implementation, it is basically a red black tree. So yeah, so let's see how we can basically create a set and how we can use in the implementation. So so for inserting the element in the set, we can use a method insert. And suppose I have inserted two twice in the set, then since as the name suggests set, so it must contain the unique set of elements, right? So if we uh, come to see the size of the set, what we can see that it has to be two, right? Because two can't be go inside set twice. So yeah. So since two can't inserted in set two times, so its size is two automatically. So so set also provides some other property for it for iterating in set. We can similarly what we have done in vector, we can basically create an iterator. We can uh, like create dot begin which points to the first element in the set. Then we can iterate. So doing iteration in a set basically its time complexity is O of n, like n is the number of elements in the set. So it is basically in order traversal. That's why it is O of n. For inserting element in the set, it is O of log n actually, and for removal also it is O of log n. For removing element in the set, we can use the property erase actually. So what erase take? It basically take the iterator pointing to the element, and so s dot iterated, so it should remove the one from set, right? So now if we check the size of like it should be one actually. Yeah. So you can see the size of the set become one. So set also provide two more properties. One is lower bound and another is upper bound. So uh, since element in set is in the sorted order, so what lower bound does, it basically what lower bound does, it basically suppose I do s dot lower bound 0. What it should do, what it does, it will basically return a iterator which will basically like points to the element which is just greater than or equal to 0. So suppose if I uh, print the value of the reference the iterator, then it's what it should like print. Let's check. be auto. So you can see that it is it points to the memory location of one. So yeah, so lower bound, as I told by definition, then one is just greater than or equal to zero in the in our current set, right? So one also upper bound. So what upper bound does, that it basically gives the element which is greater than the element that is passed in the upper bound. So suppose I push one more element in the set insert, suppose 4, and now if I, so I create one more iterator. So it should give the value of 4. Since value is 4 is greater than 2, just greater than 2, yeah. It is pointing to 4 actually, this iterator 2. Yeah. So with the help of set, what we can do, we can basically insert element in logarithmic time, erase element in logarithmic time, iterating to set in log in O of n time complexity, and yeah, we can use inbuilt methods also, like lower bound, upper bound, for doing some binary search operation also. So yeah, now the map is also very very similar to set actually. So it's also is an implementation is red black tree. So what map does, uh, we can basically like store key value pair inside map. So suppose I declare the map. So what we can do, we can basically create a key value pair in this way, like 1 equal to 2, 2 equal to 4. So yeah, so uh, iterating through map, what we can do, we can basically create a iterator equal to mpp dot begin, so iterator not equal to, By the giving the iterator second. What is wrong in the okay. So for it said for accessing the key values, what we can do that we can basically use this first 10 seconds in this way actually. So in this way we can basically iterate through the map. Uh, Also we can use lower bound and upper bound also. So I'm not going to like try here how to uh, use the function lower bound and upper bound right now. But you got the point, right? So now I'm going through an ordered set and unordered map. So these are also set, but since this as the name suggests unordered, so elements are not uh, put in a put in the set in a uh, ascending or descending order. So it will be like there will be no sequence, but element pushing in the set will be unique. So it has also functions like insert, erase, find. Also, for unordered map, it it is also like built with the help of hash tables, and it has also of functions like insert, erase, find, etc. So yeah, that's all about unordered set and unordered map. I haven't used unordered map or unordered like set in my implementation while doing the competitive programming. Yeah, we can use unordered map also actually because it actually reduces the time complexity in comparison to ordered map because ordered map basically take log of n time complexity in inserting the element to the map or erasing it. It takes log of n time complexity. So in an ordered map, actually, it don't take logarithmic time. It takes uh, like O of one time to insert elements in the map. So yeah. So for like doing the for using for the mapping purpose, we can basically use unordered map. So another thing is stack queue and priority queues. So yeah. So we all know that like a stack is basically uh, last in first out data structure. So we can basically use like a pre-built stack that is provided by the STL library. It also provides the function like pushing element in the key queue, popping the element from the last pushed item in the LIFO manner, in checking the top element of the stack, in checking whether the stack is empty or not. So all these operations are happening in O of one time complexity actually. So so let's see like how we can basically implement things, implement like use the stack. functionality. So for creating the stack, what we can do, we can basically create int stack st, and what we can do, we can basically st dot push one, st dot push st dot top. So you can see that the like st basically give the uh, top element of the stack. So for iterating through the stack, what we can do, we can basically um, do something like, suppose I want to empty the stack and like by checking it. So what we can do, while s dot empty is false, we can do st dot top. So you can see that uh, we basically uh, print the stack element, and also I have make the stack empty also. So now if I do check the size of the stack, so st dot size, you can see that since I removed every element from the stack, so its size is 0 now. To stack, so similar to stack also, it also gives a queue also. So queue is like first first in first out, right? It also provides basic similar property like push pop, front checking the front element, checking the back element, and iterating through the queue. So, so one more very important uh, container that STL library provides is priority queue. So what priority queue is? It is basically a map key by default. So inserting the element in priority queue, what we can do, suppose there are five elements, and uh, we start pushing the element in the priority queue. So uh, to check what is the uh, smallest element in the smallest element from the five element that has came. So we can basically do, we can basically uh, pq dot top. So top element will method will basically give the uh, smallest element that has been pushed by priority queue. So yeah, I have used like priority queue in like a lot of uh, programming questions while solving the competitive programming problems. So yeah, so yeah, so we have like already talked about iterators. That iterators basically uh, iterators are basically a pointers that are basically pointing to the memory location in the container. So by referencing the iterator, we can basically get the element, or by like iterating through uh, with the help of iterator, we can basically uh, loop through the container, any container like stack queue, priority queue, anything. So yeah, it also give like properties like begin, like by using like a, we have seen that like for using by using a v dot begin function, we can basically get the uh, pointed that is pointing to the first element, or by using and we can basically point to the we can basically get the iterator which is after the last element. By using r we can basically get access to the last element in the vector. By using r and like element which is just uh, like uh, like before the first element in the vector. So yeah, that's all about iterators. So, yeah, I think I have given the quick recap of what STL library is. You can uh, go through the uh, implementations and the details of STL like on the site of on the official side of C++. So yeah. Also, there are a lot of algorithms that has been provided by STL that I will be covered in next video tutorials. So thank you everyone for watching.